Next set of topics, flow control. In high-level programming languages, we have if-else constructs, we have switch, we have different types of loops. In assembly, the strategy is to insert labels in the code segment and be able to jump to them based on the outcome of condition or unconditionally. MIPS specification has two possibilities: unconditional goto or a goto based on the outcome of a condition. So unconditional jump instructions, also known as branch instructions, look like this. So mnemonic of the command J is jump to a label, so this is of course the label somewhere in our text segment, or JR transfers control to the new location specified by a register. Conditional jump instructions are designed to transfer control to a specific label. The first step in evaluation of this instruction is basically check a condition with respect to the operands that we provide. And if the condition is true, we transfer control to a specific label, otherwise let the execution continue to the next command that follows this branch instruction. Conditional jumps in MIPS all have mnemonics that start with a B, and they stand for branch of equal, not equal, greater or equal 0, and so forth. There are also versions to support immediate operands, and there is support for all conventional logical comparisons that you would find in the C programming language. The only restriction is that, unlike C, here we are only limited to the simple comparisons between the two operands, and so the expression itself cannot grow in complexity to something longer than this. So let's take a look at an example. This example is demonstrating assembly implementation of this if-else statement, followed by another statement like this. Not surprisingly, expressions like this Boolean expression that uses multiple operands has to be broken into separate steps. And in our demo here, the first step is to compute b plus 3, because the precedence of addition operator is higher than less than comparison. So we complete the arithmetic first, and then we take the result here and compare it to the register T0, which is already containing the value of variable a, and the command that implements this comparison operator is this branch if less than command. So if a is less than b plus 3, then we jump to if less, and this is our label. And here we have the command that implements this statement, which is supposed to execute only if this condition is true. But if this condition is false, then we do not jump, so instead we continue executing the next instruction, which implements the else part of our pseudocode. And from here we have to make an unconditional jump to the label that marks the next statement in our program. What's sort of curious about the implementation of this fragment is that in the original pseudocode we have a equals a plus 1 above a equals a plus 2, but in the actual implementation a equals a plus 2 is above the a equals a plus 1. So this is basically in reverse compared to the pseudocode in this approach of our implementation. On our next slide, we have a similar logic, because it's also given us an example of an if statement and another statement that comes after it. But an interesting part here is that we actually have two implementations, one implementation and another implementation. So the difference really is that in the first version, we use branch if less than, and in the second version, we invert this decision by using branch if greater or equal, because both of these logical operators can solve this condition. And so in the second version, when we flip the logical operator to greater or equal, we end up having less instructions and less jumps to make. Here we also have an example of a loop. So here our implementation is actually quite close to this while statement logic, because we check this condition at the top, and if condition is false, we jump out of the loop right here, letting the rest of the program to continue. Otherwise, we execute the actual loop workload and then unconditionally jump back to do our condition check.